اوكي يلا سلايد. احنا خلصنا المحاضرة الأولى. هسه نبدي ب بعض التعاريف الخاصة اللي لازم نكون عندنا معرفة عنها. The nervous system is formed by a number of cells which are of two types, either nerve cells, which is called a neuron, or supported cell that's called glial cells. First of all is the neuron. It is the basic structure of the structural unit of the nervous system. It generates electrical impulses transmitted from one part of the body to the other part. In most neurons, electrical impulses release chemical messengers, which is called the neuron transmitter, to communicate with each other. One are interrogated in their sum of impulses they are received from the thousands of the other nerve that are in on them. أعتقد هاي الموضوع أنا شارحه لكم ونعطيكم فكرة عنه. والرسم واضح إنه عندنا دنتري سلوت أو دنتريز، عندنا نيوكلياي سيل بودي، ومن خلال الأكزون وعندنا قدران فيرد اللي تكون هي بمثابة المناطق اللي تقوم بعملية الأوغمنتيشن أو عملية توصيل والترانسميشن، وتنتهي نبي من الأكزون تيرمينال. Other slide. Good. A neuron occur in a wide variety of shapes and size, but they are share in common features. They are all composed of four parts. These are including of the cell body, which is called the soma. It contains nuclei and organelles inside the body, provide energy, sustain metabolism activity of the cells. The other one, or the other part, is the dentaries, which is usually of about 5 to 7 process or more, highly branched up to about 400,000 to increase the surface area. لأن احنا موجودة عندنا تقريبا الدندريز أو التفرعات 5 إلى 4 إلى 7، ولكن في نهاية كل تفرع أكو مجموعة من التفرعات. الفكرة من عندها إنه أزيد المساحة السطحية، وبالتالي أقدر إنه أحس لكل المحفزات. These receive most of input and transmitted impulses toward the cell body. تنقلها إلى السيل بودي مثل ما نشوف هنا بالصورة. الدندريز هو collect electrical signal، إنه تأخذ لنا كل signal from outer يعني side of the body. والcell body integrate information signals and generate outgoing signal toward the axon. ورا ما جمعتها تنقلها من خلال الأكزون. الأكزون passes electrical signals to dentaries from another cell to an effective cells، وينتقل إلى أن يوصل إلى هي المسؤولة عن نعم جيد. فراح تستقبل الامبلسز وبالتالي يصير عملية تفسيرها داخل البرين، وننتظر شنو الريسبونس أو الكوماند اللي تجي from the brain to these parts. Other slide. Axon, which is the nerve fiber, usually single and long, is nanometer or millimeter, transmitted impulses from the soma to the target cells. Axon helco, or initial segment beginning of the axon and part of the soma. Where axon joins it or to it is the trigger zone, where electrical signals are generated in most neuron. Signals are then propagated along the axon. Near its end, the axon undergoes branches. The fourth part is called the axon terminal. Each branch of the axon ends in axon terminal and responsible for the releasing of the neurotransmitter from axon. Neuron transmitter diffuse outlet of the axon terminal to the next neuron or to the target cells. فإذا التيرمينال راح يصير بيها إفراز النيورو ترانسميتر وينتشر يا إما من terminal to another soma أو إنه مباشرة إلى التارجت سيل اللي نشتغل عليها. درس لاين. هذا السلايد أنا شارح لكم بالمحاضرة السابقة شلون يصير عملية تقسيم from the central nervous system to the peripheral nervous system. Other slide. We have the microglia, which are migrate through the central nervous system and phagocyte foreign and degenerate material. We have astrocytes. These are the supporting cells, which help to regulate the external environment or external environment of the neuron central nervous system. While we have the ependymal cells, which lie in the cavities of the brain and central canal of the spinal cord. Axon of the most, but not all, we have to remember this point, neurons are coated with a protective layer, which is called myelin sheath or term myelinated neuron. So we have some neuron, we have myelin sheath and other maybe no myelin sheath. It's formed by the following cells. We have in the peripheral nervous system is called Schwann cells, while in the central nervous system we have oligodendrocyte cell. فإذا we have شنو؟ إنه أكفة كبر رابطين للنير وقلنا على المايلين شيز، فاللي موجود بيها نسميها myelinated nerve، ولكن اللي ما موجود بيها يسمونه unmyelinated nerve. Another slide. Schwann cell, they are glial-like cells. During embryonic development, these cells attach to a ground axon and wrap around them concentric layer or centric layer of the plasma membrane. Myelin sheath of an axon is formed by many Schwann cells, but a glial cell, themselves along the length of the axon. Nuclei or nucleus is located in the outermost layer. Each segment is separated from the next by a small unmyelinated segment and called node of Ramber. وقلنا يسمونها Ramber nodules. وكانت مهمتها augmentation of transmission of the signals. Plasma membrane of the Schwann cell is about 80% lipid. Myelin sheath is mostly lipid and appear glistening white to the naked eye. بنشوفها بنتطلع عليها فتشوفها بصراحة لماعي، يعني ونشوف انه الكلر مالته يختلف عن المحيط مالته انه يميل الى الابيض. The main function of the myelin sheath help to insulated axon and prevent cross stimulation of the adjacent axon، يعني حتى نمنع عملية تداخل في الاستيمولاي، وبالتالي تمنع هذا التداخل من خلال انه اكو تقارب بين اكزون واكزون. Myelin sheath allow nerve impulses to travel with adjacent brain down to the axon, jumping from one node to Ramber node to the next. Some of the nerve fiber, which is unmyelinated nerve fiber, their axon are covered by Schwann cell, but there is no multiple wrapping of membrane, which is produce myelin. These axons connect impulses as much lower rate. هاي النوعية عملية انتقال الامبulses تكون نعم بها موجودة، ولكن less speed and length in يعني in amount of these impulses. Next slide يا شباب. Next slide. هذا هنفذ رسم تشريحي إلى الأوليغودندروسايد. لا السلايد اللي قبله. Okay. We have oligodendrocyte and we have the nodule of Ramber or Ramber nodules. وهنا مثل ما نشوف cell body, we have the neuron, we have the oligodendrocyte, Ramber nodules, and 12 the target cells. Other slide. نعبره سلايد هذا شارحه بالمحاضرة السابقة لكم تقسيم النيرف سيستم بصورة عامة. Now let's go to the nerve impulse or action potential. In the electrical current moving from the dendrocyte cell to the cell body to the axon, it results from the movement of a ion charged particle into and out of a neuron through the plasma membrane. كلها تعتمد على شنو؟ على الليفل والاماونت والconcentration of the ion. Resting membrane potential RMP. فإذا this is the first المصطلح الأول. The resting membrane potential is the potential difference that exists across the membrane of excitable cells such as nerve fiber, muscle, and the period between action potential. This is at rest. فإذا هو عبارة عن البوتنشال عبارة عن difference that exists across the membrane of excitable cells. ناخذ من excitable cells we have muscle ممكن يصير عندك firing و contraction والنيرف طبعا of course زين. فإذا هذا الفرق ايش اسمه نسميه هو شنو هو resting membrane potential is the difference in the electrical charge on the outside and inside of the plasma membrane in the resting neuron not conducting a neuron impulse. يعني البلازما ممبرين اللي موجود داخل الجزء المحفز وخارجه. بعدنا ما واصلين الى مرحله التريس، يعني ما واصلين الى مرحله شنو انه اجانا فد اوامر تؤدي الى انه يقوم هذا الجزء بعمل ما. The outside has a positive charge and the inside have a negative charge. We refer to this as a polarized membrane. At resting neuron, it is about -70 millivolt. وهنا لما نجي نشوف انه دائما الانسايد هو يكون نيجاتيف، الاوتسايد يكون بوزيتيف. بالنهايه من اريد ان اقيس ايش قد الفرق وشو قد يصير عندي اكسايتابيلتي، ونشوف انه دائما يكون الفرق ايش قد راح يكون about -70 millivolt. زياده او نقصان يؤدينا الى firing of this part. يلا يا شباب another slide. Nearest question. The nearest question is used to calculate the equilibrium difference potential for an ion in a given concentration difference across the membrane, assuming that the membrane is permeable to that ion, whether potassium or sodium or calcium. By the difference, or by definition, the equilibrium potential is calculated for one ion as the following. equilibrium potential احنا عندنا المعادلة مالتها نحتاج إلى الاطلاع عليها ونشوفها شلون صارت. next slide.
دكتور بس العفو هذول الحفظ؟
لا بابا هاي لكم المعادلات مو الحفظ، فقط الاطلاع عليها لمعرفة شلون صارت. next slide. اوكي نجي at-rest والهبن. At rest, the potassium conductance or permeability is high and the potassium channel are almost fully open. لحد الآن أنت قاعد مستريح، فعندك البوتاسيوم permeability وكل channels is open and very high. Allowing potassium ion to diffuse out of the cell down the existing concentration gradient. This diffusion creates potassium diffusion potential, which is derive the membrane potential toward the potassium equilibrium potential. At rest, the sodium concentration or conductance is low, and thus the resting membrane potential is far from sodium equilibrium potential. Is far from the equilibrium potential. فإذا at rest راح نشوف إنه عندي البوتاسيوم هواي، صوديوم هواي، فمن نقول البوتنشال راح نشوف إنه قريب من البوتاسيوم بوتنشال at rest، ولكن نكون بعيدين جدا من الصوديوم بوتنشال at rest. Because of high ratio of potassium ion inside to the outside, therefore, if potassium ion were the only factor causing the resting potential, the resting potential inside the nerve fiber will be equal to about minus 94 millivolt. فإذا during rest we have the potential for potassium is higher than the sodium, but depend on the potassium. So the level is about minus 94. The difference is due to the following. There is about 30 times more potassium inside the cell than the outside, and about 15 times of sodium outside than the inside. إذا 30 عندنا بوتاسيوم يكون أكثر بداخل، بينما إن نرجع للأوتسايد of the nerve راح نلقي الصوديوم يكون أكثر. There is also a large negative charge potential trapped inside the cells. This is why it is negative cells or negative inside. صار عندنا two causes لحد الآن. The action of sodium to potassium pump out 3 sodium ion for every 2 potassium ion that are transported to the cells. إذن إحنا نقول إنه عندنا inside the cell potassium هواي. outside راح يكون عندنا صوديوم. يصير عندنا هنا هسه impulses أو يصير عندنا stimuli. راح يصير عندنا we have the sodium potassium pump. النتيجة إنه 3 of sodium from outside راح تدخل، بينما تطلع عندنا 2 potassium from inside to the outside. Next slide.
دكتورة غير السلايد.
فإذا شفنا إحنا هنا راح نلقي إنه the special potential channel which is called sodium potassium pump moving 3 sodium out of and bringing up about 2 potassium in the cell at rest. And in resting cell there is no open channel for the sodium easily to move back into inside of the cell. However, there are some potassium channel open at all. We have the sodium causes the outside of the potential, forcing more potassium into the cell. Lots of the potassium ion inside of the resting cells. يعني احنا قلنا انه يصير عندنا stimulation راح يصير عندنا انه البوتاسيوم يطلع outside ويدخل لنا الصوديوم. There is a continuous pumping of 3 sodium ion to the outside for each 2 potassium ion pumping to the inside of the membrane. There is the fact more sodium ion are being pumped to the outside than the potassium to the inside, causing continual or continual loss of the positive charge from the inside of the membrane to create an additional degree of negativity. Therefore, the net membrane potential of sodium within the fact operated at the same time is about 90 millivolts. Next slide. Alteration in the membrane potential are achieved by a variety of the membrane permeability to a specific ion in response to the stimulation, The physiology of neuron and muscle are their ability to produce and to conduct their change or their changes in the membrane potential, such as ability is termed of excitability or irritability. If appropriate stimulation causes positive charge to flow into the cells, this change is called depolarization or hypopolarization. A return of the resting membrane is known as repolarization. If a stimulation cause inside of the cell membrane become more negative than the resting membrane, this is called hyperpolarization, which can be causes either by positive charge leaving the inside of the cell or by a negative charge enter the inside of the cell. Any potential not in the resting membrane is called membrane potential. Any stimulus that can cause action potential called threshold stimuli بدون أن نوصل إلى threshold firing level, all the cell and all the nerve will become in the resting membrane potential. مجرد أن نوصل إلى threshold of stimulation راح يتغير ويصير يا إما depolarization أو hyper depolarization. Electrical potential or electrotonic potential is a local potential and cannot be propagated and produced by sub-threshold stimuli اللي يصير دائما locally وما يصير propagation during the يعني يوصل للرانفر نود يوصل بيه augmentation يوصل لمكانات أخرى بس مجرد إنه locally. هذا بعدنا ما واصلين إلى الثريشولد اللي يسوي لنا firing sub-threshold area. Next slide. Next slide يا شباب. Action potential or nerve impulses. The shape of the action potential is the same in all the nerve, but it is augmented or magnitude change from one nerve to another, but it is remain uniform in shape. When the axon membrane has been depolarized to a threshold level, the sodium gate is open and the membrane become permeable toward the sodium. This permits sodium to enter inside the axon by diffusing process, which is further depolarize the membrane, making the inside less negative and more positive. Since the gate of the sodium channel of the axon membrane or voltage is regulated, this additional depolarization, or there is additional depolarization by opening off more sodium channel and making the membrane even more permeable to the sodium, and more sodium can be enter inside the cell and induce depolarization that open even more voltage regulated sodium channels or gate. A positive feedback loop is thus created. The explosive increase in sodium permeability result in rapid reversal of the membrane potential in that region from minus 70 millivolt to about positive 30 millivolt. At that point in time, the channel of the sodium closed, become inactivated. At this time, voltage gate of potassium channel is usually open, and the potassium diffuse rapidly out of the cells and make inside of the cells less positive or more negative. يعني نسبة تناسب راح تصير عندنا. This process is called repolarization and represent a competitive or combination of the negative feedback loop. Once the action potential has been completed, potassium-sodium bond will be excluded. The extra sodium that has entered the axon and recover the potassium that has diffused out of the axon. Next slide. هنا هذا السلايد يبين لك شلون عملية. لا لحظة يا شباب. جيد. ينظم لنا والفايرنج اريا شلون يصير عندنا تشينج ب level of the potassium and level of the sodium، وبالتالي يصير عملية الفايرنج. هادي يا شباب. شو قد بقى عندنا من الوقت؟ Yes, we have time. The phases of the potential. The first portion is the local response, is due to a slowly opening of the voltage gate sodium channel at the firing level, which is about minus 55 milliseconds. Full complete opening of the voltage gate of the sodium channel, and sodium will rush very rapidly to the cells, and membrane potential will reach to about positive 35 milliseconds, millivolt. So the depolarization is due to opening of the voltage-gated sodium channel. At positive 35 milliseconds, the sodium entrance will be stopped because of the following. The opening of the voltage-gate sodium channel are time limited for a short period, constant period, and this limit time cause depolarization will react to only about positive 35 milliseconds, and then will be stopped or closed. At this level, potassium channel are open. فإذا هنا لما نقول واحد ليش يعمل depolarization إلى تايم، نقول السبب إنه هذا البوتاسيوم channel أول مرة تنفتح من توصل إلى بوزيتيف 35، وبنفس الوقت من نوصل إلى بوزيتيف 35 sodium channel will be closed and the entrance of the sodium will be stopped. So depolarization from about 70 minus 70 to about positive 35 milliseconds is due to activation of the sodium channel. At about 35 milliseconds, opening of the sodium channel will be occur, and the potassium go outside across the concentration gradient by diffusion process. The channel are opened completely from the first time, and repolarization will be started from the level positive 35 to level minus 55. يعني راح يصير بالعكس. بالبداية فتحت البوتاسيوم الصوديوم شانل صار دخول، الآن وصلنا إلى مرحلة البوزيتيف 35 راح يصير كلوزر تو صوديوم شانل، يبدأ البوتاسيوم يطلع إلى أن نوصل إلى طبعا بدينا بمرحلة الريبولايزيشن، نوصل إلى مرحلة الماينس انسايد، راح يرجع مرة ثانية من جديد وينفتح الصوديوم شانل وتستمر العملية. صوديوم أيون concentration inside will increase, and this will cause stimulation to the potassium sodium pump to exclude sodium and carry inside of potassium till it reach to about 70 minus 70 membrane again, and resting membrane will be occur. So that after potential or after depolarization phase due to the potassium sodium pump. Next slide. Yes. There will be a loss of energy during the action potential. So after depolarization, to put the membrane potential again equal to the resting membrane by sodium potassium pump is called rechanging or recharging of the nerve. So any stimulus at this phase, then the nerve will not respond to it. Why? at negative 55 milliseconds, the sodium channel will not open. When the sodium channel is activated or inactivated, they need time more than 0.1 millisecond to return to their original configuration, and the opening of the sodium channel, again at minus 55, must be applied stimuli more than the first one. هاي مراحل الاكشن potential from the minus when جيد ممتاز from the minus 70. شوف رقم 1 sodium channel is open, that will lead to sodium entrance, يبدي الاكشن potential نوصل الى positive 50. Potassium channel is open, so potassium began to leave the cells. At this level, the sodium channel will be closed, then potassium will be decreased. After that, the potassium channel will be closed on the number 3. Next slide. J. The repolarization of the action potential. The upstroke is transmitted and the membrane potential repolarized to the resting membrane or the resting level as the result of the two events. First, the inactivation gate of the sodium channel respond to the depolarization by process of closing, but their response is slow and the opening of the activated or activation gate. Depolarization open potassium channel and potassium conductance or entrance to a value even higher than the occur at rest. The compound effect of the closing of the sodium channel and the greater opening of the potassium channel make the potassium conductance much higher than the sodium conductance. Thus, an outward of the potassium current result, and the membrane is repolarized. Hyperpolarization after potential, which is called the under threshold, for a brief point or a brief time following the repolarization, potassium conductance is higher than the rest or at rest. Membrane potential is derived even closer to the potassium equilibrium potential. Eventually, the potassium conductance return to the resting membrane level and the membrane potential depolarizes slightly back to the resting membrane potential. Next slide يا شباب. كم سلايد بقى عندنا؟ تبارك قلبي لي اياها من نزح عليك. اوكي خلينا نرجع يا تبارك.
ايه دكتور واضح؟
هذا اوكي. هنا وصلنا. جي.
أي.
يلا next slide.
هنا وصلنا.
all or non law of the action potential. هنركز عليها يا شباب. If we apply sub-threshold stimuli for the nerve, we get no action potential because it is unable to bring the resting membrane to the firing level. But if we apply a threshold stimuli, action potential will be producing and any increase in this stimuli. There is no change in the magnitude and the shape of the and the duration of the action potential. of the same nerve. The shape, magnitude, duration, and amplifier or amplitude of the action potential is the same always, all the same all the time, and no change regardless to the strength of the stimuli to the same nerve. If the stimulus is stronger enough or strong enough to generate an action potential reaches to the threshold, the impulse is conducted during the entire length of the neuron at the same length. Next slide. Refractory period. Meaning that the nerve will not respond to the stimuli during the action potential, and it is of two types. It is either absolute or relative refractory period. Absolute refractory period located between the start of depolarization until 1/3 of repolarization, the nerve is respond to the any stimulus whatever its strength. مش كده تكون قوة معناتها هنا راح يصير عندنا response due to full complete activation of the sodium channel, and so no extra channel are open. And then of about positive 3.5 millisecond or millivolt, there will be an activation of sodium channel, and this need time to return back to the original conduction or condition. Each nerve fiber has got a specific absolute refractory period, and this is important to a limit of number of action potential generated by the neuron. While about the relative refractory period is the period involved from the third of repolarization to the end of repolarization. احنا مساحش قلنا راح يكون عندنا الابسوليوت هي تبدينا للديبولاريزيشن وتنتهي لنا وين؟ بالثيرد اوف repolarization، بينما الريفراكتوري هنا ريلاتيف راح تبدينا from third of repolarization to the end of repolarization. If we apply stimuli stronger than the original stimuli or stimulus, the nerve will be respond by a new action potential because of the sodium channel will open and can come or overcome the repolarization effect of the opening of the potassium channels. Next slide يا شباب. قارنة لما نسوي between the action potential and the gradient potential. Usually in the action potential we have propagation، وعرفنا شلون يصير له propagation وشلون يبدأ الاكشن potential، وقلنا هنا الاكشن potential difference from one part سواء بالنيرف بالمصل بالكاردياك مصل، كل وحدة لها special action potential و special يعني firing level. فهنا يصير في propagation بينما no propagation long distance signal short distance signals and so on. فهنا مقارنة between action potential you have to read it and مهم جدا هذا واضح. هاي المقارنة مهم جدا. next slide بابا. Factor affecting the conduction velocity of the nerve impulses. First, diameter of the axon, which is directly proportional with the speed of conduction. All peripheral nerves are mixed nerve. The nerve contain many axons with different threshold level and different diameter. Maximal stimuli is the stimuli when applied to a nerve, it will stimulate all axons of the nerve. كل ما تكون الستيمولاي يسوي لنا تحفيز لكل الاكزون اللي موجوده بالنيرف راح يعطيني وايد propagation. Compound action potential, algebraic summation of all action potential of all axons that mixed in the nerve at the same time. والنقطة الأخرى، إذا النقطة الأولى هو تعتمد على الدايمتر وش قد يحتوي على أكزون، وكل ما يكون stimulation at the same time كل ما يكون propagated أكثر. النقطة الأخرى هو المايلين شيت، وجوده أو عدم وجوده. myelinated nerve is faster than unmyelinated nerve because myelinated sheath is insulator material, so the depolarization and repolarization will occur between the two رانفر نوديول. وقلنا انه عباره عن محطه، الرانفر نوديولز هي عباره عن محطه تعمل for augmentation of this stimuli. The action potential myelinated nerve fiber will be jumping and be called solitary conduction, while in the unmyelinated nerve fiber the action potential will be hypoxia, low level of the oxygen to the tissue, it depresses the conduction of the action potential, local anesthesia and temperature. Next slide يا شباب. The factor that affecting the excitability of the nerve, factor decrease excitability, membrane stabilizer. راح نشوف انه high calcium in the extracellular decrease the sodium permeability, low potassium in the extracellular راح تقلل لنا الاكسايتابيلتي، acidosis تقلل الاكسايتابيلتي، cooling hypothermia تقلل الاكسايتابيلتي، local anesthesia, low sodium in the extracellular part of the nerve, and hypoxia in addition to the pressure from outside. Factor that increase the excitability بالعكس، احنا كنا كل ما يكون عندنا بالاكسترا سيلولار بارت بوتاسيوم كالسيوم هوايه راح تقل الاكسايتابيلتي، بينما كل ما يكون عندنا الكالسيوم بالاكسترا سيلولار قليل كل ما يصير عندنا اكسايتابيلتي. وهذا اللي نقول عليه انه دائما يصير عندنا هايبوكالسيميا، يصير بالرينال فيلير او تو اذر كوز، فنشوف راح يدخل المريض ان شنو مور اكسايتابيلتي او في نص يصير عنده فت المريض. الكلوسيس راح يسوي لنا مور اكسايتابيلتي، high level of the potassium and potassium in the extra of sodium, sorry, and potassium in the extracellular part, and hyperthermia. Next slide. Good. إذن المحاضرة الثانية، أنا أعرف إنه المحاضرات هي طويلة وبها معلومات كثيرة، والحقيقة يعني يجوز لسوء الحظ إنه صارت بالإلكتروني. إن شاء الله إذا خلص شهر رمضان وعندنا تايم راح تكون بالحضوري، ممكن نرجع نشرح هذني بشكل أوفر إن شاء الله. اخذوا راحتكم بابا وشكرا جزيلا.
عفوا دكتور.
شكرا دكتور.